Hello, welcome back to MSci 342. So in this portion, I want to talk about what is software engineering. And I think one of the important things to do is to start off with what it is not. All right. So software engineering is not, there's two things that students come in to 342 and in their own mind they have this, and I think a lot of people do actually. But they think that software engineering is going to be some sort of special, theories that they're going to software engineering. They're going to learn really, really great theoretical knowledge that will really help produce great software. Like there's just got to be something there, and this is, I would kind of put this sort of feeling as really, there's got to be some sort of, it's almost like magic to produce great software. All right. Now, there is not any magic to producing great software. And I think that's one of the big things that we've learned over the decades since computing became a major force. We've really had to learn a lot about what is software engineering, like what can it be. But it's not a whole bunch of special theories. There's no magic to building great software. Just as there's no magic to building a great hydroelectric dam. It's a process. It's an engineering process. Now, the other thing that students come in sometimes thinking, all right, well, I want this course. So this isn't so much what they think software engineering, but they kind of think, what's this course going to be? And they think, yeah, this is going to be a chance to learn the coolest, latest technology. And every year it's something else. Oh, I'm going to do now NoSQL databases, or I'm going to do React JS. I'm going to do this, I'm going to do that. Oh, on my last co-op I did this, or I heard that people were working on this and I want to learn more about it. Basically often this sort of stuff is a short-term focus on the next co-op job. And that's not what software engineering is either. It's certainly not what this course is. For the technology, you've learned almost all the technology that we're going to use in this course. We're going to teach a little bit of additional technology, but actually not that much. The course focuses on a lot of other things. It does not focus on teaching technology or new things to add stack-wise, tech-wise to your resume. So that's what software engineering is not. Now, what really is it? Well, there is a really good answer, in fact, and it's a simple one. The simple correct answer to this question is basically the software engineering degree at the University of Waterloo. It's computer science plus engineering design. And so as I said, this can be typified as, for example, you would find it by looking at what the BSE, the Bachelor of Software Engineering at Waterloo is. Okay, so those 4 years, that program, I would say that's basically the definition of what software engineering is. Just the same way if someone asks, well, what is management engineering? Well, management engineering is management science plus engineering design. It's how we take a science, we apply it to build things. Certainly for management engineering, management science, I actually am capturing that quite broadly because it captures aspects of the computer science, the information systems work that we do, as well as the operations research, the behavioral science, all those sorts of things, sort of under the umbrella, I would call it management science. But truthfully, we have a whole bunch of sciences, an interdisciplinary mix in management engineering. Now, so we know, gosh darn it, you're not going to learn an entire degree in one course. Absolutely not. Just the same way that when students take one or two courses over in management sciences, they're not learning management engineering. They're not covering the whole thing in a couple of courses. It's an entire program. It's an entire body of knowledge. Now, so that's the correct answer. But wait a minute, what is this that we have a course on software engineering? What's going here? Well, basically, the reality is that historically we have computer science programs. Okay, so if we think about software and computers, this is a relatively young field. And so the first sort of university programs in education about computers and software, really, they formed these computer science programs. And so the computer science programs, or CS programs, they lacked any engineering design in them. Okay, they were not educational programs formed in faculties of engineering. Look at our own university. Computer science is in the faculty of math. It's mathematics, okay? So that's, so these programs, what happens is, and I went through one of these, absolutely. I have a bachelor's in computer science, a master's, PhD. So what happened to me is what happened to lots of people. You go through a computer science program, you learn all sorts of stuff. Sure, you write programs and this and that, but then you go off into the workforce and you get a job as a software developer, and you realize, wait a minute, there's a lot to building software that I don't seem to have ever been taught. And it wasn't new computer science and, algorithms and this and that, but there was a whole thing missing. And really it was this engineering design. And so what the universities did, their solution was basically, create a course or two called software engineering. Okay, well, we got these computer science programs. Our students are going off into the real world. They're reporting back that they don't really know what they need to know to build software for people. And so, wow, that must be software engineering, because engineering is about building things. So let's make a course. We'll stick it into the computer science program. We'll call it software engineering, and that'll patch things up. I mean, obviously you can't learn an entire field in one course. But this really is what we're talking about here, which is there are these multiple definitions of software engineering out there. And I certainly believe the correct one is that whole body of knowledge taught in a software engineering program like at Waterloo, computer science plus engineering design. But you're going to have a whole bunch of people who historically have gone through computer science programs. Now they're building major software systems, and that thing that was missing, or that course that they had called software engineering, is their definition of what software engineering is, which is really this engineering design, the engineering design process for software. And so there's a good example of this, I actually think, and it's this, this is very legitimate to have that. There's a lot of value, and I'm going to give you a definition here. There's a lot of value in this definition. Again, it's not the correct definition of software engineering, but you need to know this to understand where people are coming from and they talk about this. So there's a recent book out, just published, called Software Engineering at Google. It's got a lot of great information in it, where the engineers and former employees of Google talk about what software engineering is and what you should know is software engineering. And one of the things they say, so this is a direct quote from the book, is, and I like this, these are good definitions, is that programming is the immediate act of producing code. So you sit down, you type some code, compile, run it, that's programming. That's not software engineering. What they say software engineering is they say software engineering is the set of policies practices and tools that are useful. Oh, sorry, not useful. Sorry, that are necessary to make, this is kind of long, to make that code, and what they mean by that code is that code that you've written up there by programming, useful for as long as it needs to be used, and, oh, there's an and, allowing collaboration across a team. End quote. So that's pretty long. Software engineering is a set of policies, practices, and tools that are necessary to make that code useful for as long as it needs to be used and allowing collaboration across a team. So let's note some really important points about this, is that out of this, they draw a notion about policies, practices. All right, first off, policies and practices. That sure doesn't sound like computer science. It doesn't sound like theoretical knowledge. Certainly not high tech. They're getting at people and processes. This is the way we need to work. This shows up explicitly at the end of their definition as well. Collaboration across a team. So they frame the start of their definition and their end that the biggest issue here is, how do we work together? How do we form a software team? And this has really been a big realization in the software field, is that this is one of the biggest issues faced, is how do you put all this together? And it's really, what is the engineering design process? And certainly there are some tools that you're going to use to aid and to make those processes, those practices, policies, that collaboration more feasible. We always build things to help us get stuff done. Now there's the other thing, which is, certainly useful. We want utility, we want high quality software, but this long bit, this is getting at time. And this is a really big thing that's stressed in the book, is that Google also talks about software engineering as it is sort of programming integrated over time. It's a really sort of nerdy definition, but this real notion that if you're going to have a long-lasting software system, it takes a lot of effort in how is the environment and the team, how do you build it, how do you design the software, how do you keep it updated and maintained. So if you're only going to write a program that you need something that day, it's a one-day effort, it doesn't require much software engineering. If it's going to last like Google search has for more than a decade, well, that's a much bigger endeavor. And there's a lot more effort into keeping that sort of system alive and going over the years. All right, so it's with this basically, that we have what we have in MSci 342. Basically we've got this notion that it's this engineering design process. What is the engineering design process for software? And so likewise, in MSci 342, this course we're taking, we view SE, and I put it in double quotes because we know what I really mean by software engineering, but for the purposes of this course, software engineering, just like it is for the Google folks, software engineering is the engineering design process for efficiently creating high quality software that solves a client's problem. All right, so we're focused on the engineering design process, and it's the software engineering design process. You actually learn lots about engineering design. You've got it in lots of your courses. That's why you're earning an engineering degree. We're focused here in this course on a particular engineering design process, one for software. The great thing actually is that that process has a lot of elements to it that are applicable for a lot of project management, lots of projects that you're going to work on in your life. So, there's lots of things in the world where people are saying, well, let's adopt these agile practices from the software field. They seem to work really well. So we're going to use Scrum as our key process. Scrum can be used for all sorts of projects. It's not just software. Efficiently, we want to actually build this software in a timely manner. We don't want to waste our time, all right? High quality, we want to build it so that it doesn't have lots of bugs in it. How do we do that? And most importantly, I guess, is it actually needs to solve the client's problem. It's real possible to build a bug-free piece of software that no one wants. We want to build one that actually people want. Now, you go from this and what the Google definition was, and in the software engineering at Google book, they nicely break down then software engineering into three parts. Okay, so software engineering at Google basically breaks down software engineering into three things. They break it down into culture, they break it down into processes, and tools. And you're going to see that we do the same thing in this course, because what they mean by this is they mean people and teamwork. And we're going to talk about people and teamwork quite a bit. It's a very important part of the engineering process for software, the actual processes. And so we'll talk about what is the development process that we follow. For example, often you have code reviews in a software process. And really importantly, how do we utilize testing? So that gets at a lot of the quality issues, and how do we do that? And tools. We're going to get more into depth in this course. One most important tool for software engineering is version control. We're going to talk about how to use GitHub for teams. You've used it already as an individual, but we're going to use it as a team now. There's also things like build systems. We're not really going to deal with that. We're also not going to deal with static analysis, but these are the things that as you go deeper into software engineering, the practices and tools and things that you'll do, and then as well as the notion of continuous integration and delivery. And again, we will probably not delve deeply into those things. There's only so much time in one course. But these are the aspects of really what Google sees, and it's a good breakdown, a way to think about it. What are the culture, processes, and tools, or think about it as people, teamwork, or development process in our tools. All right. So, what is software engineering? Well, it's that whole body of computer science plus engineering design. Historically, again, we've got these courses called software engineering, or in our case, principles of software engineering. And these sort of are they were a stopgap measure in computer science programs, in my opinion, to teach some of the necessary knowledge for actually developing software. You can't capture an entire field in one course. And so what we really need to understand is what we're getting at in this course, and what we're going to be talking about as software engineering, is the engineering design process. How can we efficiently create high quality solutions that software solutions that solve a client's problem? That's what we're looking at. All right.